Volpe is involved because military installations are national multimodal transportation facilities at their core. We're among the best in the world, I would say, at supporting such facilities. I would say that we have also a very deep knowledge in safety, whether that's transportation safety or energy safety. And we can bring this type of expertise to Department of Defense facilities around the world and really create this sort of Department of Defense, Department of Transportation, Volpe partnership to ultimately create more resilient facilities and to increase national defense and increase national security. Air Force installations are very much at the intersection between where energy and transportation meet and matter a lot. The loss of energy, and by energy I really mean not just electricity but also fuel, the loss of that also means the loss of transportation and ultimately compromised national security. So what we did at Volpe is, collaborating with our project partners, we assessed the risks and the vulnerabilities of unreliable energy at Beale Air Force Base in California. And we identified strategies to enhance the operational resilience of the base. And the end result is effectively more resilient energy at that Air Force installation, and the transportation being more resilient and ultimately enhanced national security, both at Beale and hopefully elsewhere. There's really two components of the effort that Volpe had helped the Air Force with, and Beale Air Force Base specifically. Number one is the baseline assessment, and two is helping support their energy architecture decisions. As far as the energy architecture decision support, we used a tool that's well known in the industry called analytical hierarchy process, but we customized it using the Volpe resilience framework.
It has a real-time risk monitoring and situational awareness. So ICT, information and communication technologies, are key components of the framework. So it's the engineering component, it's the monitoring and information communications component, and finally it has a very strong decision support component. The process enables us to learn and to improve. So in a sense, it's not a static response and recovery kind of ER strategy, but it's a dynamic, has a dynamic learning component. You never bounce back, you improve.
Our framework is peer-reviewed. We also factor in adaptive prevention through enhanced situational awareness. We think about predictive elements to anticipate evolving threats. So threats are not this static thing that you just plan for and have a big list for. You learn things as you go, and you can come up with ways of really evolving your system and predicting things as the threats do evolve. The results are now being used to not be theoretical, not be generate some report that sits on a shelf. They are right now being used to procure real hardware, real technology, and other resilience enhancements to the Beale Air Force Base. Beyond that, we are documenting lessons learned and best practices that we found along the way, along with our partners on the project, and standardizing these to the extent possible so that ultimately we can use this energy resilience enhancing framework on all Air Force installations across the world, if not any Department of Defense installations across the world.
The most important impact that I'm really very happy about it is that we identified the application of microgrid, renewable energy and alternative energy resources. The evidence-based findings would be applicable to other pilot tests, but also other installations DoD-wide.